Corrective Actions, Part 4. Explain the possible causes and corrective actions for a sudden loss of gas production, combined with a low volatile acid concentration in an anaerobic reactor. The cause is a toxic material is being introduced into the reactor, which is causing the microorganisms to be inhibited or killed. The corrective actions would be to dilute and recycle from the secondary reactor, or to attempt to identify the toxicity, its source, and eliminate it from the wastewater flow. 5. Explain the possible causes and corrective actions for a gradual loss of gas production, combined with a high volatile acid concentration in an anaerobic reactor. The cause is the reactor is imbalanced and is tending towards going sour. Assuming that temperature is not a problem, the obvious problem is excessive loading of organics in too short of a time to the reactor. Reduce the loading if possible, and or pump sludge more frequently for shorter durations. 6. Explain the possible causes and corrective actions for intense anaerobic reactor foaming. Problem: intense anaerobic reactor foaming. Cause: intermittent reactor feeding. Corrective action: feed reactors continuously. Intense anaerobic reactor forming. Cause: separate feeding or inadequate blending of influent and waste activated sludge. Corrective action: blend influent and waste sludge wise before feeding. Intense anaerobic reactor foaming. Cause: insufficient or intermittent gas mixing. Corrective action: confirm that reactor mixing system is operating well. Repair or replace. Intense anaerobic reactor foaming. Caused: excessive amounts of grease or scum in reactor feed. Corrective action: limit quantities of grease or scum in the reactor feed. Seven. Outline an action plan to use if an anaerobic reactor is starting to become upset or go sour. A through F. A. Monitor volatile acid to alkalinity ratio and pH. B. Reduce loading to the reactor by reducing COD loading. C. If needed, increase alkalinity through the addition of lime, sodium bicarbonate, magnesium hydroxide, or sodium hydroxide. D. If upset or sour conditions continue, this would be the occasion to check micronutrient levels, look for toxicity issues, and check volatile solid levels. E. Once the volatile acid to alkalinity ratio has decreased and pH returns to normal, begin to gradually increase the COD loading rate to normal. F. Continue monitoring acid to alkalinity ratio and pH. 8. List the methods for testing for biogas leaks. Online, Offline. A. Online. Gas detector. Soapy water. B. Offline. Pressure test with water or inert gas. Then vacuum test. Note, always use spark-proof tools and keep any open flames away from all reactor equipment and structures to prevent fire or explosion. 9. Describe what should be done to a gas handling system after a foaming incident. After a foaming incident, it will be necessary to clean all gas handling equipment that was affected by the foaming event. This would include the use of water, solvents, and air as specified in the O&M manual or as recommended by the manufacturer. 10. Describe how odor problems can generally be managed. Many odors cannot be eliminated, only controlled to an acceptable level. Control measures can include source reduction, good housekeeping, ventilation, air scrubbing, and or chemical treatment, oxidizing agents. 11. Discuss the problems associated with hydrogen sulfide gas. Hydrogen sulfide, in the presence of moisture, forms weak sulfuric acid, which is highly corrosive to a wide variety of materials, most metals, electrical equipment, and concrete. The gas in low concentrations produces a very noticeable odor. The characteristic odor is often described as smelling similar to rotten eggs. At relatively low concentration, the gas is very toxic and causes a serious problem in confined spaces. Prolonged exposure to hydrogen sulfide desensitizes the sense of smell. If you smell it, you need to yell. If you stop smelling it, you need to run. Explain how the generation of hydrogen 12. Explain how the generation of hydrogen sulfide gas can be controlled. Hydrogen sulfide gas is typically associated with low oxygen conditions. Hydrogen sulfide can be removed from reactor gas with an absorbing agent, such as an iron sponge. Decreasing the source of sulfur going into the reactor could also reduce its production. Iron salts can also be used to tie up the sulfur going into the reactor.